Yeah, why
And
don't we
your
start off
bit.
with you? What's your bit?
My bit today is all about ionic bonds. And so every atom is happy. The atoms that transfer turn into a positive atom, and then the other one becomes stable with 8 valence electrons. Back to you, Miss Covalent.
Thank you, Miss Ionic. Alright, so for covalent bonds, there are 3 different kinds. There's single covalent, double covalent, and triple covalent. So what they do, this kind of bond is where atoms share electrons to make them all stable. So that they each have 8 valence electrons. So for example, here's the diagram of H2O, water. There are 2 single covalent bonds, one here and one here, where hydrogen is sharing with oxygen and hydrogen is sharing with oxygen. This is just a diagram of this. However, even though there are 2 single covalent bonds, it does not mean that there's a double. This is an example of a double covalent bond, where 4 are being shared. So it's 1, 2, 3, 4, 5, 6, 7, 8. So that one's stable. And then 1, 2, 3, 4, 5, 6, 7, 8. So this one is also stable. And I even have an example of a triple covalent bond. I'm not sure what this element is, but I think it's an element. And anyways, all of the atoms are stable. See?
I have a chart
1, 2,
too.
3, 4, 5, 6. Yes.
I think it's time that we see an ionic bond chart. Don't you think, Miss Covalent?
Yes.
So, this is a classic example called salt, and it is where sodium and chlorine come together through an ionic bond. So sodium has 1 valence electron, and it can easily be transferred to chlorine, so that chlorine has 8 valence electrons, and sodium is positive.
Yes, how interesting.
I think that is very interesting.
As I was saying, so this atom also contains 2 single covalent bonds right here. So this is a very complicated atom. However, covalent bonds have the ability to make much more complicated atoms. Anything you can think of, covalent bonds can make it work.
A few moments later. "12 seconds later."